This is Imani. This is India. This is Sydney. And I'm Brandon.
Okay, so today we're going to be using the principle of Kirchhoff's laws to find the current on this here series of resistors. Now, first things first is determining the directions of the current. Now, since it wasn't given, we can just go ahead and make those. And I'm going to let India do that.
Okay. So, like he said, since we weren't given current, we're gonna have I1 in this direction, and I2 here, and I3 can go this way. And then, so the reason that we find the direction of our current is to understand junction rule. So in this case, junction rule states that the current going in is equal to the current going out. So in this case, our I2 equals I1 plus I3.
Okay, so now we got our junctions, we got to do our loops, and we're going to do those following Kirchhoff's voltage law. And basically, all the voltage law states is that the total of all voltages when combined equals 0. So that means from these two loops that we're about to make on the left side and on the right side, our total sum of voltages on each loop will be 0. So here on the left loop, I'll start this off. We're going to have, which way? We'll go ahead and follow our current. So the loop will be going this way. All right, so if we're following our current, that means we're leaving from the positive terminal of our EMF. So we're going to have a positive 10 volts. Then from there, because we're following our current, remember current moves from high potential to low potential, so that has to be negative. So that means this current here that travels to this resistor will be negative. So minus I1 times, what is that, 10 ohms? And then we have I2 traveling this way, and our loop follows that current still, and will also be a negative. So we'll have I2 and 10 ohms. And all of that is equal to 0 because of the voltage law. And then Brandon will be here in a sec to handle the right loop.
So I'm Brandon, and I'm going to do the right loop. So on this right loop, we're going to go against the current. We're going to go against I2 on this one. So the loop is going to go this way. It's a bad loop, but you get the idea. Loop's going to go this way. So I'm going to add on to something Imani said earlier. We're going to take out 10 on this side. So we're going to divide by 10. So we're going to end up with just volts minus I1 minus I2. And then once you divide 10 over that way, it's 0 equals 0. So, back to the right loop. The right loop, we're going to have a negative 30 because you're going down on the EMF. You're going on the negative side of the EMF. You're going to have negative 30 volts plus I2 times 10. It is positive because you are going against the current. So you're adding voltage. I2 times 10 ohms. And then since we're going against, still, you're going against I3, so it's going to be plus, again, because you're still adding voltage, I3 times 20 ohms equals 0. And it's still equal to 0 because of the voltage law. And just like on the left side of the loop, on the right side, or on the right loop, you can divide by 10 again, so it'll get you negative 3 volts plus I2 plus I3 equals 0.
Okay, so my name is Sydney, and to finish the problem, we have to set up a matrix to solve. But first, we have to get all the three equations alike. So you're going to put voltages on one side and the currents on the other. So starting with the first one, I1 is 1, and I2 would be negative 1, because we move it to the other side. I3 is positive 1, and then there is no voltage, so 0. And for the left loop, we have a negative 1 for I1, a negative 1 for I2, there is no I3, and a negative 1 for the voltage. And for the right loop, we have no I1, a positive 1 for I2, and a positive 1 for I3, and a positive 3 for the voltage.
Okay, Brandon here, back at it again. So we're gonna set up the matrix, and the way we're gonna set up the matrix, it's gonna be a 3x4, and like Sydney said earlier, we're just gonna put everything in. So it's gonna be 1, negative 1, 1, and 0, and that's for our base I equation. That's for the junction rule equation. Then it's gonna be negative 1, then 0 for our I3, and then negative 1 for our voltage. Then it's going to be 0 for I1, positive 1, and then a positive 3 for our voltage. So then we're going to hit second quit. We're going to go to second matrix, math, RREF. Then we're going to go to matrix again. And this is going to give us our resultant. And that's our answer.
So, as we saw earlier, our answer in the matrix left us with these three numbers. Now, how you can translate these are per each of the currents in order. So I1 is negative 1/3 amps, I2 is 4/3 amps, and I3 is 5/3 in amps. Now, if you remember Kirchhoff's earlier rule, the current in has to be equal to the current out, and from that we were able to determine that in this specific case, I2 was equal to I1 plus I3. Now we can take these values and see that we're correct because 4/3 amps is equal to negative 1/3 amps plus 5/3 amps. That's how we know we're correct.